In this short video, I'm going to present to you the basic functions of most synthesizers, which have been derived from the Minimoog architecture. In particular, I will give you a basic example of subtractive synthesis. In pigments, like in all virtual analog synthesizers, we find the same structure as in the Minimoog. I showed you that in the video on the history of music synthesis. Basically, you have 3 oscillators and a way to mix them to pick the waveform that you're going to use for each oscillator. The filtering section, the modulation section, the envelopes, etc., etc. Let's try first a single oscillator which is generating a sawtooth waveform. Okay, then what we can do is add the 2 other oscillators using the same waveforms. Basically, what we get is just a louder signal with a slight modulation, which is due to the fact that they are not perfectly tuned. But if we slightly detune them a little bit more from each other, then we get into more interesting results. And of course, the sound is richer and has more harmonics. And then we can apply some filtering, and in particular, a low-pass filter to remove the most aggressive and highly pitched frequencies to soften the sound. Another thing we can do is to shape the envelope of the signal, which means we can change the attack, the sustain level, the decay time to get the sustain level, and the release time. Okay. Another important feature which is characteristic of the Minimoog is the glide time, which allows to change the portamento time length and therefore to link successive notes in a legato mode. And finally, we can add modulations to the signal. Modulation here means the dynamic change over time of various parameters of the signal. For instance, we can modulate the frequency of the played note and therefore make a vibrato effect. We can change the amplitude of the effect, but also the frequency of the modulation. Similarly, we could modulate the volume and get a tremolo effect, or modulate the cutoff frequency of low-pass filter with some resonance to get some wah-wah effect, etc., etc. The wah-wah effect is just a change in the cutoff frequency using the resonance of the filter. All these basic features have been used in synthesizers for over 50 years now and are still very much applicable and relevant in all music styles.